Hello wonderful person, this is Anton, and you're looking at the telescope that was used to send two very specific signals to a nearby star, hoping that someone will reply to us. This was a project started by the so-called Sónar, which is actually a music festival in Barcelona, that decided to use this beautiful telescope in Norway to try to transmit messages to a nearby star known as GJ273, although it's also known as the Luyten star. And although the messages themselves will not arrive to this star until 2030, and we're not actually going to hear anything back, if anything, until 2043, I wanted to investigate the star system itself because one of the recent papers analyzing the star system suggests that it might actually have a habitable world after all. Let's talk about this, and welcome to What the Math. If you were to look in the vicinity of our own solar system, you would discover a few really interesting stars. Within approximately 15 light years away from us, you can actually discover at least a few confirmed exoplanets, with some of these exoplanets even being in the habitable zones of their star systems. One of such really interesting stars is a star known as the Luyten star, named after the Dutch-American astronomer Willem Jacob Luyten, who originally described the motion of the star a few decades ago. And although a Luyten star is what's known as a red dwarf, it's an M5 type star, and overall there are actually quite a lot of these stars in the vicinity, so technically nothing should be making this particular star special, there is something that makes the star unusual, and that something is related to its activity. It is actually really quiet. It's not very active at all, it produces practically no flares, and interestingly, it seems to also have the lowest rotational speed of any M-type dwarf we've seen. In other words, it spins really slowly. I believe it takes approximately 116 days for the star to spin once, and that's very slow for really any star. That means that this star spins with a speed of about 150 meters per second, which also might suggest that it produces almost no magnetosphere and practically no flares or nothing really dangerous that could potentially strip planets of their atmosphere and of course their water. Just to give you a comparison, our Sun spins at least 8 to 9 times faster, and some of the other red dwarfs spin even faster than that. So that's why this is actually one of the more important properties of this particular star system. Also, unlike other red dwarfs, even though it does have a regular temperature of about 3100 degrees Kelvin, it actually seems to be extremely massive compared to some of the similar stars we've found. In other words, it seems to be right at the border between being an M-type star, which is usually very active. There are also a lot of these stars in the galaxy, and they also seem to possess very powerful magnetosphere, and also a typical K-type star, which is a lot less common but also a lot less active, and we've actually always believed that we're going to be able to find our next Earth-like planet around a K-type or a G-type stars. So in other words, this particular star seems to be right at the border. It's not very active, but it also will probably live an extremely long life, trillions of years as a matter of fact. G-type and K-type stars only have a few billion years of lifespan, whereas M-type stars do actually live really long, simply because of the way they circulate hydrogen on the inside. One of the major reasons M-type stars live much longer than G-type and K-type stars is because due to their size they're able to mix the entire volume of hydrogen on the inside, and this allows them to use all of their hydrogen, whereas K-type and G-type stars, due to their larger size, are not able to mix all of their hydrogen and only have so-called convection zones where hydrogen is allowed to be mixed as only part of the volume. Which is why when these larger stars get really old, they essentially expand and throw out all of the extra hydrogen and all of the extra materials into the rest of the galaxy. This does not happen with M-type stars, which allows them to live much longer. And because of this star is going to survive for hundreds of billions or possibly even trillions of years. Which also means that if it has any planets here, they might have a very long time to develop, well, actually a lot of things, including of course life. But what kind of planets have we discovered here? Currently there are 2 confirmed and 2 potential planets in the orbit of this star. The 2 larger planets orbiting on the outskirts are very likely Neptunian in size and mass. These 2 planets, referred to as D and E, were only discovered last year, and they're most likely present, but they're not particularly exciting because they're going to be really cold, they're going to be very similar to Neptune and Uranus, and they're also unlikely to have any habitable conditions either around them or in their atmospheres. So in that sense, they're exciting, but not particularly exciting. One of the first planets discovered in the system was the closest planet to the star itself, and this is a planet that essentially orbits so close to the star that the temperatures here are very likely similar to the ones on Mercury or even Venus. So in that sense, this is definitely not the planet we're actually expecting to have any exciting conditions on the surface, but because its mass is extremely similar to the mass of Earth, it's only about 18% more massive than planet Earth, we do think that this is probably one of the more interesting desert-like planets in the vicinity of the solar system. But the last planet is obviously the most exciting one, and that's also the one that the scientists in this paper are investigating. This planet, known as GJ273b, is essentially in the habitable zone of the star system. It's also what's known as a super-Earth, so it's about 2.9 masses of planet Earth. But all of the investigations conducted by the scientists in this paper do suggest that it has a very, very high chance to have what's known as a global ocean, as you can see in this simulation, and it does have a very high chance of being habitable as well. But unlike other star systems with habitable planets in them, such as the famous TRAPPIST-1 system that you see right here, or the closest exoplanet to us, Proxima b, what makes the Luyten star very, very different and what makes GJ273b very exciting is that this star, like I said before, is very, very inactive. It's extremely different from all of the other red dwarfs we've discovered, and most importantly, it doesn't seem to produce enough flares or really any other radiation to strip the potential planet here from atmosphere and from liquid water if it's already there. But if this planet is tidally locked to the star, it most likely looks something like this. It's basically what's known as an eyeball planet, with the star-facing side being exposed to constant sunlight and essentially having liquid ocean here, and the darker side being always covered in ice. So it still doesn't really look like planet Earth, but it does have a potential for having this global ocean and very similar to Earth conditions, at least to some extent. And because of this planet, this is why the scientists back in 2017 and 2018 decided to send 2 signals to the star system, hoping that maybe someone replies after all. It does have a very high chance of having habitable conditions on the surface, but chances for having alien intelligent life here are currently somewhat slim, mostly because we've previously investigated the star with SETI, for example, and we haven't really found any signals coming from it. Nevertheless, this is probably one of the more exciting nearby star systems, and it's also one of the more exciting planets simply because of the possibility of having an actual liquid ocean in the habitable zone, and also because of the star system itself. And interestingly, in this particular paper, the scientists even simulated the creation of the star system and realized that there are probably a lot of different objects very similar to the objects here in the solar system that could have delivered all sorts of different materials needed for life to kickstart here as well. In other words, the star system very likely has similar composition and also similar water-bearing and organic-bearing asteroids that do have a chance for life to kickstart here on this planet known as GJ273b. And the final conclusion in this paper is that this planet right here could potentially be one of the more habitable worlds in the vicinity of our star system, and also definitely deserves more investigation in the future. Right now there haven't really been a lot of papers about this particular planet, but it does sound like a very exciting star system and something we might consider exploring in a little bit more detail. And at a distance of about 12.3 light years away from us, this is obviously one of the closest star systems to us, so it's definitely a lot easier to see and investigate than some of the other planets out there. But unfortunately there haven't been a lot of studies about this star system, so we don't really know much else about it. Once we learn more though, I'll make sure to follow this up with another video. So that's really it for now. Make sure to subscribe, share this with someone who loves learning about space and sciences, and maybe come back tomorrow to learn something you may have not known before. And I guess in 2043, if we don't hear anything back, it's also very likely that there's really no one living on this planet, or at least no one willing to reply to us. But anyway, until we discover more about the Luyten star or GJ273b, that's pretty much it. I'll see you tomorrow. Consider supporting this channel on Patreon, because it does help me quite a lot, and maybe consider supporting this channel by buying the Wonderful Person t-shirt you can also find in the description below. Either way though, I'll see you tomorrow, space out, and as always, bye bye.